In the span of just 5 months, the aviation world was shaken by 2 catastrophic crashes involving Boeing's new generation 737 MAX aircraft. On October 29, 2018, Lion Air Flight 610 plunged into the Java Sea, killing all 189 people on board. Less than half a year later, on March 10, 2019, Ethiopian Airlines Flight 302 met a similar fate, with 157 lives lost. These incidents, involving a brand new plane, defied conventional explanations and sent shockwaves globally, prompting an urgent quest for answers into what went terribly wrong. The story of the 737 MAX begins years earlier, born out of intense competition. Boeing, a titan of aviation, faced a formidable challenge from its European rival, Airbus, which had launched the highly successful A320neo, a fuel-efficient single-aisle jet. To compete, Boeing needed to quickly upgrade its own best-selling 737 line. The solution was the 737 MAX, an updated aircraft designed to offer better fuel economy and performance while retaining the core familiarity of its predecessors, crucial for airline adoption. To achieve greater fuel efficiency, Boeing fitted the 737 MAX with larger, more powerful engines. However, these engines were too large to fit in the same position as previous 737 models. They had to be placed further forward and slightly higher on the wing. This seemingly minor change had a significant consequence: it altered the plane's aerodynamics, causing the nose to pitch up more aggressively in certain flight conditions. To counteract this, Boeing introduced a new software system, designed to subtly push the nose down when needed. This new software system was called the Maneuvering Characteristics Augmentation System, or MCAS. Its primary purpose was to enhance flight stability and ensure the 737 MAX handled similarly to older 737 models, despite its aerodynamic changes. Specifically, MCAS was designed to automatically push the aircraft's nose down to prevent an aerodynamic stall if the plane's angle of attack, AOA, became too high. In essence, it was a safeguard, intended to make the updated aircraft feel familiar and safe for pilots without extensive retraining. The critical flaw in MCAS lay in its reliance on a single angle of attack, AOA, sensor. Aircraft are typically equipped with 2 AOA sensors for redundancy, allowing systems to cross-reference data. However, MCAS on the 737 MAX only used input from one sensor. If this single sensor malfunctioned and sent erroneous data, MCAS would activate repeatedly, relentlessly pushing the plane's nose down. Pilots, unaware of this new system and its potential to command significant flight control, would then be battling an automated system based on false information. Crucially, Boeing did not adequately inform pilots about MCAS. It was not explicitly mentioned in flight manuals, nor was specific training provided for it. Boeing's rationale was to minimize retraining costs for airlines, making the 737 MAX a more attractive purchase. Pilots were reportedly unaware of the system's existence, let alone its potential to exert strong control over the aircraft. This lack of knowledge left crews unprepared to diagnose or counteract the system's malfunction in a high-stress emergency, turning a design flaw into a deadly trap. During both the Lion Air and Ethiopian Airlines flights, a faulty AOA sensor began feeding incorrect data to the MCAS system. Believing the aircraft was nearing a stall, MCAS repeatedly commanded the nose down, despite the pilot's desperate attempts to pull it up. Each time the pilots corrected, MCAS would re-engage, pushing the nose down again. It became a relentless battle between man and machine, a struggle for control based on misleading information. Ultimately, the pilots were overwhelmed, and both aircraft, tragically, succumbed to the flawed system. Another layer of complexity lay with the Federal Aviation Administration, the FAA. For years, the FAA had increasingly delegated significant safety certification tasks to Boeing itself, a practice known as Organizational Designation Authorization, or ODA. This meant that Boeing employees, rather than independent FAA inspectors, were responsible for approving many aspects of the aircraft's design and systems, including MCAS. This delegation, intended to streamline the certification process, created a potential conflict of interest and reduced independent oversight, allowing critical flaws to go undetected. Underlying these technical and regulatory issues was intense corporate pressure. The race against Airbus to bring the 737 MAX to market quickly and affordably was paramount. There was a strong financial incentive to minimize any new design elements that would require extensive pilot retraining, as this would increase costs for airlines and make the MAX less competitive. This pressure influenced decisions about MCAS design, its reliance on a single sensor, and the lack of comprehensive pilot information. Speed to market, unfortunately, overshadowed thoroughness in critical safety considerations. The tragic loss of 346 lives led to an unprecedented global grounding of the entire 737 MAX fleet for 20 months. Boeing undertook a massive effort to implement a software fix for MCAS, incorporating redundant AOA sensor inputs and additional safeguards. The crashes severely damaged Boeing's reputation and financial standing, leading to billions in losses and a crisis of public trust. While the 737 MAX has since returned to service with updated software and enhanced pilot training requirements, the incidents serve as a profound, costly lesson in aviation safety, corporate accountability, and the critical importance of robust oversight.